For lesson 2.1, we're going to talk about simplifying algebraic expressions. So our new vocabulary words shouldn't really be super new, but we're just going to define some things so that we have some background. So we're going to talk about terms, coefficient, variable, like terms, and distributive property. So first we're going to talk about terms. A term is just constants, meaning numbers, variables, or both, separated by addition or subtraction. And so an example of a term would be like 3x plus 5 minus 2x squared. So 3x is a term, 5 is a term, negative 2x squared is a term. Does that make sense? So everything separated by addition or subtraction are different terms. Next is coefficient. A coefficient is a constant or a number. Constant and number are the same thing. In front of a variable. And so once again, like I'm not going to ask you like what's a coefficient, but it's just good background knowledge to know so that when I'm talking and I say, what is the coefficient in this? Or like if I, like during a lesson or something, or the coefficient of y is 3, or something like that. It's just good background knowledge to know. Next, we're going to define a variable. So a variable is a letter that represents a number. A letter that represents a number. And then within terms, we have something called like terms, which we've already kind of talked about. And like terms have the same variables with the same exponents. And so a good example of this would be like, some examples are 2x and 3x. Those are like terms. They both have an x. Let me zoom in some. 5xy and 4xy. But even further, we could also say within that 5xy and 4yx, those are also common terms. And the reason why is because with multiplication, like the order doesn't matter. Just like with addition, right? If I do 5 plus 4 or 4 plus 5, I'm still getting 9, right? And if I do 5 times 4 or 4 times 5, I'm still getting 20. So order doesn't really matter with multiplication. So if they're in different orders, that was something that popped up in my honors algebra 2 class on their, I think their quiz. And a lot of girls got it wrong because they were like, well, it's x, y, and yx. I can't combine those. But we could flip that around, and then they would be like, yes, ma'am.
On the warm-up, we had like on number 4, it was like AB2.
Yep. They are not. Why do you think not? The exponent, yeah. So although order doesn't matter, exponents do matter. So if I had 5x squared y and 4yx squared, those are common, right? Because the square is still with the x, versus 5x squared y and 4xy squared, not common. Because the squared, so the exponents have to match, the variables have to match, and then those variables' exponents have to match. Yeah? That's the same reason why I can't combine 4x and 4x squared.
Okay.
Cannot combine those. Okay? Does that make sense?
Yes.
Cool. Another thing to point out is that even like the sign doesn't matter. So like I could do 3x squared and negative 2x squared. Once again, I'm just looking to match up those exponents and those variables. The sign in front does not really matter.
So the 3x squared and negative 2x squared
Can go together, yes. We would just subtract instead of add.
So it'd just be 1x squared?
Exactly.
Also be written as just x squared?
Yep. Yep. Good. Okay, and then I totally wrote into my distributive property area, but that's okay. I will just make it work. So for distributive property, our definition is multiplying an entire expression by a constant. Which, remember, constant means number. So multiplying an entire expression by a constant. So this could look like 3 parentheses 2x plus 4. We've already done some of this. So whenever there's a number out in front of our parentheses, we can distribute that number. So we multiply 3 by everything inside the parentheses, each term inside the parentheses. So 3 times 2x would be 6x, and 3 times positive 4 would be plus 12. So we've already done a lot of that, and hopefully you guys feel pretty comfortable with distributing. And let's look at some examples. So this section says simplify by combining like terms. So once again, we're going to be combining common things. So I've got a 2x and a 2x. I've got a 5 and a 5. So we're going to be grouping our like terms and combining them by whatever sign is or operation is in between them. So 2x plus 3x is what? 5x. And 5 plus 2 is 7, right? Not bad. Okay, B, we have negative 5a plus an a, negative 3 plus a 2. So negative 5a plus 1a gives me what? Negative 4a. And then negative 3 plus 2 gives me negative 1. Okay. Letter C, we've got some decimals and we've got some exponents. So once again, these x squareds go together, but the x does not, right? The x does not, and then we also have a negative 5. So I have 5.3 plus 1.7. If I was doing this without a calculator, I could totally do this. 10, 4. So 4x squared. And then there's nothing to combine with the negative 3x, so that just gets brought down. There's nothing to combine with the 5, so that just gets brought down. Doing okay? All right, here we've got a fraction. So we've got negative 1/2 b plus 1b. So a lot of times with fractions, like I will do that off to the side. I'll do negative 1/2 plus, and it's 1. So I'm going to actually write 1 as 2 over 2. Is 2 over 2 the same as 1? Yes, right? Because, so that is the same as 1. Because 2 divided by 2 is 1. So what's nice about the number 1 is you can make it whatever denominator you need. But if this was negative 1/52, then I could do 52 over 52 and have a common denominator, right? So then I just do my numerator. So negative 1 plus 2 is 1/2, which some of you might have looked at that and been like, once again, I knew that. Just 1/2 plus, negative 1/2 plus 1 is 1/2. That's totally okay. So we have 1/2 b. Now something important, especially when we do stuff off to the side, is making sure that we put that variable back with its number. Feeling good about combining like terms? Okay, now we're going to do some with distributive property, which once again, we've already kind of talked about. So I always think of like hippity-hoppity distributive property. Something with distributive property that I always do is I always draw my little arrows or little hops, because it's like my checkpoint to be like, okay, I did that one and then I did that one, especially if there's like a bunch of terms. So I'm going to do it as I go. So 3 times 2x is 6x, and then 3 times y is plus 3y. And so I do those hops as I go to make sure that I'm not missing any important terms. Which, like I said, when there's just 2 terms, it's not as bad. But yes, ma'am.
Wait, how is 3 times
I don't know.
2x?
Not a clue.
3x.
Yep, no, it's not, right? It's definitely 6x, right? And then as soon as you said that, I looked at it and I was like, nope, that's not right. That's not right. There we go. 6x plus 3y. Thank you. All right, and then this one, we've got a negative 4, so that negative goes with the 4. So we've got negative 4 times 1x, so that's negative 4x. Negative 4 times negative 2y is going to be what? Positive 8y. And then negative 4 times positive 6 is going to be what? Negative 24 minus 24. Good. Now, at this point, if there were any common terms, we could then combine like terms. But we've got an x, a y, and a number, so we stop. Okay, C, we've got 1/2. So I think of when you're multiplying by a half, it's the same as dividing by 2. Okay, so a half of 6 is what? 3. A half of negative 2 is what? Negative 1. And a half of negative 20 is negative 10. Now, I might also rewrite this and just get rid of that 1 that's in front of the 10, or in front of the b. If you left a 1 in front of an exponent, or I mean in front of a variable, that would not bother me. But it is more mathematically correct to have it be invisible. Okay, questions on that one? And then lastly, we have 1/3, which once again, just like a half, it's like dividing by 3. So anytime you have 1 over a number and you're multiplying that fraction, it's like dividing by the denominator. So I have 1/3 of 6, so I'm going to do 6 divided by 3, which is what? 2. So I have 2a. And then I have 1/3 of negative 12, so I'm going to do negative 12 divided by 3, which is negative 4b. And then I have 1/3 of negative 20, which does that go evenly? No, so I'm just going to say negative 20 divided by 3.
So you don't do the division?
No. If I said leave your answers as a decimal, then we would have to come over here and do it, and that'd be what? 6 point something. 6.6 repeating. But if I don't say anything, I would just leave it as a fraction. Like, this is how I would leave it. Okay? Questions on that one? Okay, let's go to the next page. All right, so on the second page, we have some more advanced problems. So once again, more terms, more exponents, stuff like that. So a lot of times when I have problems like these, I will definitely go through and use a highlighter or my little like boxing method, and I will highlight all of the like terms by certain colors. So here I am highlighting. The green doesn't really show up very well, I'm sorry. And so I have the x squareds highlighted in red, the x's highlighted in blue, and the numbers highlighted in green so that I can look at it all. You could also do underlining, like 1 underline, 2 underlines, 3 underlines. So I have 5x squared minus 2x squared, which is what? What's 5 minus 2?
3.
Thank you. 3x squared. I've got 3x minus 8x, which is negative 5x. And then I've got 2 minus 10, which is negative 8. All right, you guys take a second and do B. Okay, did you guys get 3x minus 5y plus 9? Perfect.
Order we put it in?
No. I usually go alphabetical and then numbers at the end. So like X comes before Y in the alphabet, so I put the X first. It does not really matter though, but that's what I do. Helps my brain. All right, letter C, what do I have to do before I start combining terms? Distribute. So I have 3 times 2x, which is 6x, 3 times 1, which is 3, 4 times x, which is 4x, and then 4 times negative 2, which is negative 8. Did y'all get there?
Yes.
Yeah. And then 6x plus 4x is 10x, and then 3 minus 8 is
Negative 5.
-5. Good. Did you guys already try D? Yeah? 10x?
It's 2x plus
Let's see. 6x plus 3 minus 4x plus 2. So then 6 minus 4 will be 2x. 3 plus 2 will be 5. Okay, so IJK. So -4 times -4 times -2 is +8. And then 6 minus 4 is 2x. 3 plus 8 is 11. There we go. I think I was looking at the one before when I was writing. Might be. Now is it right? Yes. Okay, good. All right, this one, we've got distributive property, but with more than 2 terms. So we've got 5 times 5y, which is 5y. 5 times 2x, which is 10x. And 5 times -3, which is -15. Good. Now, we have this minus sign. What is in front of that parentheses? A 1. So it's a -1 that we are going to distribute. Anytime you have a negative in front of a parentheses, you're going to distribute that negative as if it was a -1. So I have -1 times 2y, which is -2y. -1 times x, which is -x. And -1 times -10, which is +10. And then we just bring this +4 down. Basically, whenever you have a negative in front of the parentheses, you switch the sign of everything inside that parentheses. So, yes, ma'am.
If it's negative,
It becomes positive.
okay.
Yep.
Thank you.
You're welcome. So I've got a 5y and a -2y. I've got a 10x and a -x. And then I've got a 15, a 10, and a 4. Okay. So 5y minus 2y is going to give me what? 3y. 10x minus 1x is 9x. And then -15 plus 10 is -5, right? And then -5 plus 4, -1. That's fine. Totally fine. to do negative 15 plus 14. All right, number 4, we've got a fraction. So we're going to distribute that fraction. So 1/2 times 8x is going to be what? 4x. Good. Let's keep it quick. 1/2 times 10 is 5x. Good. So remember, when we're multiplying by a fraction that's 1 over something, it's really like dividing by that bottom number. And then, do I need to distribute anything for the second parentheses?
Yes.
What? But does it change anything? No. So if it's just a plus nothing, I usually just drop the parentheses.
What if 1 times negative 9? 2.
It's still a negative 2.
Oh, makes sense.
Yeah.
Thank you.
You're welcome. So then 4x plus 3x is 7x, and 5 minus 2 is 3. How you doing? Good. Let's try one more. This one's probably the most difficult one. Let's do G together, shall we? So I have 1 over 5, which means we're dividing by 5. So I have 1/5 times x, which is just going to be 1/5 x. I can't, like, the only other way you could write this is x over 5, but I like to just write 1/5 x so that it's a full coefficient in case I need to combine. I see that 1/5. And then I have 1/5 times 10y, which is going to be what? Good, 2y. And then 1/5 times negative 25. Great, awesome. So there's that first parentheses. Divided by the bottom number, yep.
How is it 5 times, wait, oh, never mind.
Good. And so now I've got this negative 6 I'm going to distribute. So negative 6 times 1/5 x. So negative 6 over 1 times 1 over 5 is going to give me what? Negative 6 over 5. Good. So I'm going to have negative 6 over 5x. And then I have negative 6 times 1y, which is negative 6y. I know. So then I've got x's.
Is the whole fraction negative?
Yep. Y's, and I just have one number. So for the x's, though, it gets a little tricky, right? I have 1/5 minus 6/5. So I'm going to write it off to the side, 1/5 minus 6/5.
Wait, no, negative 5. Negative 1.
Wait. Negative 1, right. 6 minus, or 1 minus 6 is negative 5 over 5, which is a negative 1. Good. So negative 1x. So negative x, and then 2y minus 6y is negative 4y. And then there's nothing to combine with the 5, so we just leave it. Good. Questions, comments, concerns? Awesome.